Okay, hello everyone and welcome to this TU-Automotive webinar, the next automotive data revolution. My name is Jamie. I'm a project organizer over at TU-Automotive, based over in London, so it's coming towards the end of our day. But very pleased to welcome our panelists for today's webinar. We have Rajiv Phugat. He's the Chief Technologist of Industry Solutions, Automotive and Aerospace and Defense at IBM. And we have Michael Morgan, who is partner and co-leader of the Global Privacy and Cybersecurity Practice at McDermott, Will and Emery LLP. As the title suggests, we're going to be talking a lot about data in the automotive side of things, but we're going to be looking at some of the more interesting angles of it. So specifically, we would have seen a lot about blockchain at the moment in terms of security. So that's really going to be the focus of this webinar, is addressing blockchain within the automotive side. So without further ado, we're going to switch over now to Rajiv, who's going to kick things off for us with a presentation discussing more on this topic. Just a reminder to you all that the recordings will be made available in the next day or so. So we'll be able to send you the full recording of this webinar. At the end of the two presentations, we'll also be addressing, putting your questions to our panelists today. So if you have any questions, please use the questions tool to submit those directly, and then I'll be able to put them to our panelists at the end. But that's quite enough from me, so I'll hand it over to Rajiv now. Rajiv, we'll just be switching slide share to you now, so ready when you are.
Thank you, Jamie. Jamie, can you see my screen okay?
It's coming through, Rajiv. I think you just need to, if you fire up the presentation, we should be able to see it. Yeah, there we go. That's perfect.
Okay. Thank you, Jamie. So hello, everyone. This is Rajiv Phugat. As Jamie said, I'm the CTO for Industry Solutions and Strategy for Automotive, Aerospace, and Defense for IBM. And, you know, I would like to talk about some of the industry imperatives and what's going on in the automotive industry from data perspective. Now, blockchain is just one angle, and I think Mike is going to cover a little bit more in terms of, you know, how blockchain is impacting the industry from security perspective and regulation perspective. I'm going to focus a little bit more on, you know, how data in general is shaping this industry and how data is being collected and used by the automotive industry as a whole. So the three primary factors which are impacting the automotive industry today are the consumers themselves, because consumers are so powerful today that they have you know, specific expectations from a digital engagement perspective and experience perspective that they are influencing how the OEMs or the automotive manufacturers create their products, and not only products but also services. The consumers also are compelling the OEMs to co-create with them, and one of the examples is what we are seeing in the industry is because of this consumer expectation, OEMs have started putting things like CarPlay, which is an Apple offering, and Google, Android, in the car, and the only reason is because the consumers are expecting to expand from their mobile devices into their cars and vice versa. So consumers are one, you know, specific factor which are disrupting the automotive industry. The other one is mobility, and when I say mobility, it is not about the mobile phones, but it's about tapping into intelligent vehicle capabilities. So infusing cognitive into vehicles, making vehicles more interactive and interesting from so tapping into intelligence, you know, inside the vehicle, creating the personal advisor, which is intelligent and interactive. You know, that's where IBM is playing, that we are, you know, creating some of our solutions are more focused on the experience from intelligence using cognitive solutions like Watson into the cars. The other one is ecosystem. So OEMs are not only players in the automotive industry anymore. There are a whole lot of other players which are influencing how the OEMs create their products and offer their services. And ecosystems are enabling, new growth areas for the OEMs, new ways to make money. And one of the biggest examples is data monetization. How OEMs are collecting the data from the cars and using that data to make more money. For example, one of the use cases is usage-based insurance is a big example of that. So ecosystem is also playing a key role in disrupting the industry. It is not only about the manufacturer, but it's about a whole lot of other players, whether it is communications companies or data collection and data monetization organizations, or telematics companies. There are so many different players into the market today who are influencing the cars of tomorrow. So on basis of these, we have been focusing on three things within IBM, and this is all based on the industry imperatives I was just talking about. Those three areas of focus we have are the customer experience itself. As I said, we are infusing Watson using artificial intelligence and cognitive systems to enhance the experience of the driver and the passengers in the car. So that's the experience in the car, but even outside of the car, how do you buy a car? How can you use the augmented reality and virtual reality to be able to see what type of car you would like to drive and be able to configure that car while you are at the dealership, right? Or when you're sitting at your home using the interactive experience, you should be able to configure your car and see what kind of car features you would like to see in your car and be able to configure it for yourself, and that exact same car will be delivered to you. So that's the experience piece, how you not only drive the car, but even outside of the car, how do you experience for a specific product, as well as the services. The second focus area is transforming the operations, and these operations are focused on how do you make the manufacturing and supply chain for the OEMs more effective, more productive, and be able to deliver the products with minimum cost and best possible quality. So that's the transformation of operations focus area, where we have our industry solutions focused on. The blockchain, as Jamie said, one of the focus areas of this discussion is blockchain. And blockchain is not only being used in making sure that every single electronic component in the car is delivered in a way that it is tested completely the way it should be working even before it is put in the car. So we are using blockchain technology to create solutions to provide quality and compliance using blockchain, and also providing safety and security of the vehicle using blockchain. One of the other, bigger use cases for blockchain is to infuse blockchain in the supply chain for all the players in a car. The car has, thousands of components, and those components come from different suppliers. So how do you make sure all the suppliers are providing quality products and what goes in the vehicle with the best possible quality and minimum possible cost? And that's where we are leveraging blockchain-enabled supply chain as one of our solutions, leveraging the blockchain technology. The third focus area is the product itself. So OEMs or products and services for the manufacturers as well as the suppliers is the third focus area we have. And that's where, the connected vehicle comes into the play. And also the other areas of focus we have in products and services are cognitive commerce. So how you should be able to communicate with your car and be able to do commercial transactions from your car. The car should be able to not only order the products and services which you want while you're driving on your way, but also be able to pay from your car. The third area is continuous engineering. So after the product has been launched into the marketplace, how do you provide a feedback into the engineering so that they can modify the product as per the feedback from the market after the product has been launched into the market? And that's what is the focus of continuous engineering. Again, security is a key in every single process we talked about, right from inception of a product until it is operating into the market. So security is a key for us, and we are using security in every single aspect of the value chain of automotive industry. So those are our three key focus areas. So now coming back to the data, how data is shaping this industry. One of the things I talked about was the connected vehicles. So the vehicles today are connected all the time, leveraging the network. And, some of the use cases are basic use cases from the core telematics units of the vehicle, where the vehicle is transmitting the data, and the data is being collected to make sure the car you are driving is safe, it is secure, and it is providing the convenience you need. On top of the telematics data, the core telematics platform, then there are connected services, for example, infotainment. We talked about intelligent personal assistant in the car, which is voice-enabled. You can interact with it. You can order things you want through commerce. You can analyze the behavior of the driver, how the driver is driving the car using the data which is being collected. Where is the vehicle at any point of time? So location services and concierge services. If you want to book a hotel while you're driving, you should be able to do it. Or if you want directions which are not being provided by your navigation system, you can actually call or interact with a personal advisor, which is enabled by cognitive technologies to provide you the concierge services. The third layer is mobility services, and this is, ride sharing, for example, is one good use case in that. To be able to share a particular car with multiple people is the ride sharing aspect. And peer-to-peer sharing, you want to use your car but be able to also share it with somebody else when you are not using it. And the asset is being utilized by multiple parties and being, that way you're making more money from that asset. The fourth layer is the autonomous vehicle itself, that we are collecting data from the autonomous vehicle, but also providing the data to the autonomous vehicle by means of the edge analytics. You should be able to collect and make decisions within the vehicle itself, but then take that data and be able to optimize how the autonomous vehicle drive itself, whether the vehicle is safe or not. All of those use cases are part of the autonomous and ADAS system. So those are the four layers I wanted to talk about. I think I have taken more time than what was allocated to me. So Jamie, over to you, and I'll wait for the Q&A session to answer any questions in this area.
Thank you, Rajiv. And actually, you were spot on with the time, so no worries there. I think some people may have had a couple of issues with logging on at the start, so just to make you all aware, you all will all be receiving the recording. So the first minute or two you may have missed, that'll be coming through to you in the next day or two. And also just another reminder, do keep those questions coming in. As Rajiv alluded to, we will be having Q&A at the end of Mike's session, which is just coming up now. So if you do have questions, please submit those, and I'll be putting those to our panel at the end. But for now, we're going to head over to listen here from Michael Morgan, who is the partner and co-leader of Global Privacy and Cybersecurity at McDermott, Will and Emery. As Rajiv alluded to, we're going to be focusing a bit more on the security element of blockchain with Michael, who I believe is going to be freestyling this, as I don't think we have some slides here. So, Mike, I'm going to hand it over to you, and you've got 50 minutes to talk about blockchain and cybersecurity. Over to you.
Great, thank you, Jamie, and thank you, Rajiv, for interesting discussion. I want to discuss how global privacy and cybersecurity issues come into play in the things that Rajiv discussed, and how new developments like blockchain technology and vehicle autonomy make certain issues like cybersecurity more important. And I also want to talk briefly about how these issues play out in a global industry like the automotive industry around the world. And let's start with just some of the basics. I mean, the defining characteristics of connected vehicles is that the vehicles can pretty much go anywhere, and you can have complex data streams that cross multiple borders. So you can have a US manufactured vehicle that's sold in Europe that runs applications that were designed in Asia and elsewhere around the world. And as those data streams cross international borders and state borders here in the US and national borders in the EU, they become subject to different rules. And governments and the law generally doesn't care if you're subject to laws elsewhere with respect to data streams. Rather, you have to comply with each and every one of them that might apply to a particular data stream. And it's not just the law, of course, but expectations by consumers can vary from region to region, from nation to nation. So what you're expected to do, both in the operation of existing connected car applications and use cases, and also in the newer ones, is that it may well vary from region to region. And I want to briefly discuss the different cultural and regulatory issues that are in play around the world, starting with the US. And to very briefly touch on these issues, the US is a regulation-light jurisdiction where you can generally do what you want to do, including complex data analytics and complex uses of existing data, including legacy data, as long as you sort of say what you're doing. And so long as you tell the truth and your data doesn't get compromised. If you do get hacked and there is a breach, your obligations are often determined by local laws where data subjects reside, where they reside, which can be complicated because we're increasingly seeing more breaches that implicate laws under 100 jurisdictions because you have 50 states and 50 countries. And you have developed regulatory oversight in certain areas, but not others, and you have a robust private litigation mechanism here in the US. Europe is an area that within the auto industry is receiving a tremendous amount of attention now. And compared to the US, in Europe, there are more genuine concerns about data use and advanced analytics and advanced uses, being intrusive to individual rights and conflicting with consumer expectations, which are different, and being so complex that it can be difficult for the automaker to be transparent in their dealings with customers. So you have pretty complicated rules in Europe dealing with, when it's lawful to process data. And in many instances that would not be applicable in the US, you have a requirement to obtain consent, and not the type of consent that we tend to think of in the US, like a click-through agreement or whatnot, but a thoughtful consent that has various features, such as collection of data before or obtaining consent before the data processing is started, consent that is very specific as to what consent is being given, that is fully informed about the uses that consent is being given to, and that is expressed in a clear and affirmative way, in a way that just simply for folks that have dealt with U.S. privacy issues and consent under U.S. privacy law can seem quite different. So there are a range of situations where consent can be required in Europe that simply do not often arise under U.S. law. These can be situations where consent is being obtained for purposes of if you're storing information, consent can be required there. If there's sharing of information, sharing of personal data with, for example, social media operators such as Facebook or other third parties, often requires consent. The use of data that was like legacy data may often require consent, and use of data for direct marketing purposes can often require consent. Also in Europe, there are a variety of other fundamental principles that govern the use of data that, for example, do not exist by and large under the U.S., except in certain limited circumstances. One of the most important is there are a series of sort of data subject rights that exist in Europe, including the rights to access data, the rights to portability of data, the right to transfer that to another third-party service provider, the right to erase data. These are rights that only exist in narrow circumstances under U.S. law, but they do exist under European law. And there are a whole variety of other issues, likewise under European law, limitations on your ability to use information for purposes other than what it was initially collected for, requirements to minimize the use of data, and also restrictions on storage of data beyond the time period that's absolutely essential for the use of that data. And the key point here is that for U.S. participants, there are common U.S. practices like click-through consents that simply are not going to cut it under European standards. And in the development of products, it is often important at early stages to think about how to incorporate different privacy standards into the products that are being developed. And as a third area of contracts, I want to briefly talk about China, where China's laws have evolved in recent years and do have implications for the auto industry as to how data can be kept. And China regulates many aspects of privacy and cybersecurity, and its laws do give the Chinese government broader surveillance powers with respect to automotive data. And I don't want to talk a lot about this, but I do want to talk very briefly about China's cybersecurity law. China's new cybersecurity law does apply to critical infrastructure providers, which include transportation providers and would likely include automotive providers. And with respect to those, there is a requirement, by and large, to retain the data within China. And that requires, subject to certain exceptions that are a little beyond the scope of this presentation. But under Chinese laws, you do have different rules that are going to be applicable to how you structure the providing of these services. So I think one of the key challenges facing the auto industry is how to develop and roll out products across so many jurisdictions, especially where data use laws and expectations are varying from region to region. And the most advanced uses of data often require more analysis of that data, which by and large implicate more fully the differences between these regions. Now, to be sure, there are ways to work through them and ways to deal with the differences, but those are things that need to be addressed during the development process for those applications. Now, let's move to more novel applications of more cutting-edge uses of data. And if you look at blockchain, for example, the fact is that there's very little law or regulation that targets blockchain directly. There are particular applications or solutions that obviously are going to trigger existing requirements. Things like smart contracts, for example, would trigger contract laws in most jurisdictions. And they also can trigger consumer protection laws, financial regulations, etc. Bitcoin transactions are generally lawful in the vast majority of jurisdictions around the world, but there are often really challenging questions about what Bitcoin is. So here in the US, depending on which judge you ask, Bitcoin can be money, it can be a commodity, and it can be property, each of which triggers a whole bunch of different regulatory rules that are long developed, over many decades or centuries, dealing with what rules apply in those categories. There was a 2015 decision from the European Court of Justice finding that Bitcoin transactions are exempt from that, VAT, thus treating Bitcoin as money, not a commodity. So what we see, and what we've been doing a lot with our clients on, is the development of structuring of agreements with blockchain providers, because there are so many startups and other providers that are out there that are developing blockchain solutions, and you want to be very careful in your contracts if you have a development project to looking into blockchain applications for your company. You want to be very careful how you structure the relationship with the provider. Who's going to take on critical responsibilities and take on responsibilities for the development of particular features, such as security applications, and who's going to own the product that is ultimately developed as a result of that. Those are really important issues. There are real privacy challenges with blockchain, going back to what I was discussing before. If you have a blockchain solution that you're exploring, you need to think about how is it that you're going to enforce, for example, the European Union's right to be forgotten, or the right to delete information that exists, in some instances under U.S. law. How are you going to actually put that into place with respect to blockchain, where the data is, very function? One of the key features of blockchain is that the data is immutable and it's not subject to being altered or deleted. That's one of the key security features of blockchain. How do you do that while at the same time respecting the rights of data subjects to delete information about them? And depending on where the blockchain resides, does that trigger cross-border data rules? When you have data that goes from one jurisdiction to another jurisdiction, in many instances that transfer is unlawful. So with respect to a global blockchain solution, how do you maintain that solution without violating those laws? So those are real challenges, because blockchain itself has this wonderful feature of being highly, highly secure if it's done right. But the challenge is oftentimes that the regulatory environment that exists for it is so unclear that it's very hard for developers to develop with confidence in this space. And when you talk to regulators about this, there isn't a lot of expertise in this space about how these solutions should be operating. So blockchain is part of the solution, and the security features of blockchain are definitely part of the solution. But at the same time, it presents some real fundamental challenges to the legal system and to the lawyers that are working on these things to figure out a way to do it that is consistent with existing laws and regulations. Next, I want to talk a little bit about vehicle autonomy. Vehicle autonomy raises one sort of really overriding issue. Much of the vehicle autonomy issues are data privacy issues, which are similar to the ones that we talked about earlier. But cybersecurity really comes to the fore with respect to these issues. And the challenge is that we need to be prepared for a different type of attacker once we network vehicles and network driver functions for vehicles. And connectivity in autonomous functions creates, really for the first time, the risk of significant ransomware and system-wide vulnerabilities on a scale that were not previously faced by other connected car applications. For the first time, we really need to worry about nation-state vulnerabilities. And there are, of course, countries that have dedicated significant resources to ensuring their ability to take down critical systems. And they will want to have the ability to bring down the autonomous vehicle network. this is going to require on the part of participants in the autonomous vehicle development programs a constant vigilance to try to keep down state attackers and to keep them out of the systems. This is going to be a difficult process, and part of the challenge that companies face in this area is that state attacks are very difficult to attribute. And if you are, we often advise global companies, and when global companies have been hit with a state-sponsored attack, you may very quickly know that you've been attacked by a particular foreign government. But the challenge is that if you're a global company, you may have operations and sales of millions of vehicles in those countries. What do you do in that context? You're going to have a very difficult decision from a business perspective, and really for a whole variety of other reasons, including insurance reasons, attributing that to a state actor. So state actor attacks are a real challenge in this area, and I think we all could probably think of a couple governments that would like to have the ability, and whether they use it or not, they would like to have the ability to bring down an AV network. And part of the challenge of autonomous vehicles has to do with their attack surface, which in cybersecurity terms is basically what is the network that is being attacked? How vulnerable is that system to being attacked? And much of the power of a lot of the autonomous solutions that are developed require large amounts of connectivity, and with additional connectivity comes additional vulnerability. And I think perhaps one of the most important questions that the industry is facing now is, the extent of connectivity of autonomous vehicles and the extent to which autonomous vehicles interact with their infrastructure and other vehicles. There are different approaches to this, and some really good work is being done in the space by a number of organizations. But the important point is that every instance of connectivity means that the vehicle is accepting a data stream and needs to secure that data stream against attack. So as I wrap up here, because I know I've gone a couple minutes over, the challenge here is a development challenge and a regulatory challenge. Regulators have been cautious, and there's been recent guidance from the UK and from the US on this. They've been cautious on these issues and cybersecurity regulation for AVs, and rightly so. It's very difficult to regulate with any degree of specificity and in a way that is not going to impede autonomous vehicle innovation. There are some very good people working on regulatory bodies, but the regulatory agencies have real challenges in terms of keeping talent and bringing sufficient technological and cyber expertise to these difficult issues. I think it's going to be really important for those that are involved in autonomous vehicle development programs to think hard about cybersecurity best practices. I know it's front of mind for a lot of them, but it's a real difficult time in history because there's a real push to drive these products out. It's inevitable that there are going to be deaths from autonomous vehicle rollouts, and we know from history that the public's going to be far less accepting of AV deaths, even if AVs are demonstrably safer than human-driven vehicles. And if that results in a public backlash against the technology, the likely result is bad regulation that will make it harder for the industry and for the public. So I know I've gone a little bit over, but Jamie, I'll pass it over to you.
Not at all. Thank you, Mike. So we'll move on to some questions now. So if anyone's got questions for our panelists, please do send them in. I think we may have lost the connection with Rajiv. I'll just check out. Rajiv, are you still online? Okay, so I think I'll just try and get Rajiv on board. So Mike, I'll put the first question to you, then we'll kick things off for you. So the question we have is, we read every day about our networks and information breaches. The question is ultimately, why should I trust my car to unsafe processes at the moment?
Well, the same question could be asked about any connected device. I mean, why do we trust any of our information to the systems? I mean, that issue has been in place since the late 60s when we started to connect when we started to provide sensitive information over an insecure network. So it's a very fair question. I think that the reality of the situation is that we do know how to secure networks. If it's done right and you follow a rigorous process, it can result in safety. In the companies that I've worked with, where there is a database that is, sort of the keys to the kingdom or the kingdom itself, when careful attention is paid to those systems do not get breached. It requires a rigorous process of aggressive testing, and in the cybersecurity context, oftentimes what that may require is the development of a red team whose job is to break the security, and you entrust that team to go out and do the things to your system that any dedicated hacker would do. So if you're vigilant and you're focused on it, you can achieve some level of security. But I think it's a very fair question, and I think it's incumbent on the industry in their development process to have strong best practices so that we do not have a headline-grabbing instance where, for example, every vehicle on the road turns left, to give a lot of weight to those concerns.
Okay, we'll stick with you, Mike. Rajiv seems to be having some connection problems, so hopefully we'll get him in before the end. But the next question I have is, there's an automotive ISAC security effort, but it's very closed in terms of participation. It's very industry-driven. But especially when we're looking at autonomy, there needs to be engagement with public safety officials, traffic managers, etc. The person who's asking this question represents a municipal government, and they ultimately want to know how can they be involved in this security.
That's a great question. I actually hear that not only from governments, but you hear from industry too. Information sharing programs have not been highly successful. There are challenges on many sides of the equation. I don't have an example from the automotive industry, but I know from other areas of critical infrastructure, I've had clients and other utilities express tremendous frustration at their ability to get information about vulnerabilities affecting their peer organizations. But at the same time, those organizations will tell you that they do not want to share information because of, legal risk, privacy concerns, a whole variety of, including in some instances, antitrust concerns. This is a really big challenge, and when it comes to things like addressing, identifying, and responding to state-sponsored or highly sophisticated attacks on autonomous vehicle infrastructure, it is an absolutely critical issue. But I can tell you that from my discussions with law enforcement and industry, I'm not very optimistic about our ability to get to increase the flow of information sharing across organizations. I mean, the fact is that governments are not going to want to turn over their best stuff, because if you're in an espionage type situation and you know about an attacker tool that your adversary is using, you don't want them to know that you have it, by and large. So unless there's a fundamental shift in kind of the way that those issues are looked at, there's not going to be a dramatic uptick in the sharing of information. Now, it's not all gloom and doom. There is some valuable information sharing, and I can think of, I've had instances, even in the last couple months where we've been able to get valuable assistance from the government in terms of helping us to attribute particular attacks. But those examples are not as common as we might want them to be.
Okay. Moving on to the next question, we've got quite a consistent one coming up here, and I'm quite curious to hear your thoughts as well, Michael. A couple of questions around the implications of autonomy and insurance. So I'll just pick one at random here, but the question is, assuming there will be a mix of autonomous and driven vehicles, what will the impact on liability and insurance be? Quite a few people are actually quite keen to get your thoughts on this, so I think we should go with this.
Sure. Within the insurance context, I have to concede that I really think that the challenge from the automaker side is going to be that once the autonomous vehicle features are rolled out, that basically changes the dynamic of the relationship between the company and its customer in fundamental ways. So when the customer drives off the lot, you don't just have residual responsibility for existing and latent defects, but you also have responsibility for the continued function of that vehicle to the extent that there are autonomous functions that are contained within them. And that means throughout the life of that vehicle. When you have vehicles that are interacting in the wild with human-driven vehicles, the autonomous vehicles need to be in a position to protect themselves and to and I think to document the decisions that they've made. These vehicles need to be smart enough. There needs to be sufficient logging of their activities so that they can justify the decisions that they've made. Vis-a-vis human actors, I think we can fairly assume that we should be able to design autonomous vehicles that interact in a sensible way with human drivers and that take into consideration human drivers' failings, from including inattentiveness and drunkenness and other sorts of activities. The vehicles need to respond to that. For the insurance industry, I think the insurance industry, I know players in the insurance industry that are eager to develop these types of products to ensure autonomous vehicle rollouts, because it's new revenue streams for them. And the insurance companies are eager to roll out those products. It makes money for them. And I think the insurance industry will be standing there ready to assist. But it's not going to be, but I think in terms of the way the courts are likely to look at it, I think there's going to be some really tricky issues in terms of application of existing auto liability laws and negligence laws to autonomous vehicles. And it's going to be interesting to see the way that these cases are ultimately litigated. We could have there will be some important cases probably brought on a class-wide basis about autonomous vehicle functions and how they interact with humans. So I think we'll just need to see the way that plays out.
Fantastic. Thank you, Mike. I think we have Rajiv back online. Rajiv, are you there?
Yes, I am, Jamie. For some reason, you were not able to hear me.
No worries. We've got you back. Glad to hear it. Well, we've got a bit of time, so Rajiv, I'll put the last couple of questions to you then. So one question we have here is, how are you using blockchain to secure connected vehicle ecosystems, including devices and drivers?
Yeah, so that specific use case, I don't think, blockchain is only technology which is being used there. There are multiple technologies which needs to be combined to create that solution. Now, device security itself, we have agents which actually run in the TCU or ECU of the car, and we have specific algorithms which are written to understand the anomalies in the behavior of the car itself. So it is constantly understanding, gathering and understanding the data on the fly. And if it sees any anomaly in that data from, predefined behavior, then it generates an alert to the operations center, and the operations center can then define actions, whether to stop the engine of the car or to alert the driver that your car has been, hacked or there is some other security-related threat. So that's how we provide security for the vehicle by running these agents in the TCUs and ECUs and connecting them to the on-prem operations center for security.
Okay, thank you, Rajiv. The next question I have here is blockchain limited to the encryption of the payload, or does it have its own transport layer security? What protocols does it work with?
Yeah, so blockchain can work with different layers of security. So it is not running at the transport or layer. It is running at the application layer, So I'm not a security expert from blockchain perspective, so not able to answer that question specifically, Jamie.
Not to worry. I think we'll do one more question. I think we are probably done here. So, interesting question here. So, Rajiv, I'll put this to you again. The question asks, can you talk about where you see blockchain in the automotive aftermarket, i.e. services, maintenance garages, and body shops, on the dealerships and independent outfits? So taking a bit of a look outside traditional sort of OEMs, as it were.
Yeah, so one of the very common use cases of applying blockchain in the aftermarket is to beat the counterfeit parts market, right? There's a whole black market of counterfeit parts. So creating a end-to-end traceability of the parts, right from the manufacturer to the dealership or the workshop where the car is being repaired, on what parts are being installed in the car and whether those parts are authorized OEM authorized parts or not, is one of the use cases where we are applying blockchain to beat the counterfeit parts market. The other use case is, how the workshops are able to install certain updates for the software in different TCU and DCUs. So providing over-the-air updates for different components in the car or the automotive using blockchain in a secured manner, so that they are authorized software updates which are provided and certified by the OEM and the supplier. So that's the other use case we are working on for providing secure over-the-air updates for various components in the car. Those are a couple of use cases I can think of aftermarket.
Fantastic. Thank you, Rajiv. And that really does conclude this webinar. Just a reminder to everyone that the recording will be made available in the next couple of days. Also, to bring your attention to the fact that this webinar has been run in the lead up to the Consumer Telematics Show. This show takes place January the 8th, 2018. Hard to believe that 2018 is nearly here. It takes place just before CES, over 500 attendees. And some great speakers, including, I'm pleased to announce, we have Rajiv and Mike both coming along in person to talk more about blockchain. So if you are interested in this topic and all the automotive technology that's going to be disrupting the industry in 2018, then this really is the show to come to. But for now, I'd like to thank you all for listening, and a big thank you to Rajiv and Michael. I'm sure I would agree you've provided some fantastic insights today. But that really does conclude it today, so thank you all, and it's goodbye from TU-Automotive HQ.
Thank you, Jay.